Okay, today's question will be give the foci or vertices and the eccentricities of ellipses centered at the origin of the xy plane. In each case, find the ellipse's standard form equation in Cartesian coordinates. The given coordinates of foci is 0, plus minus 3, and the eccentricity is 0.5. First, we can have the eccentricity equals to E equals C over A, and in this case the foci equals 0 plus minus C. So here you can just plug in C, since C is plus minus 3, so C is 3. So we can put like A equals to C over E, which will be 3 over 0.5, which will be equal to 6. So here you can have C equals to square root of A squared minus B squared. So this means that C squared equals to A squared minus B squared. So this will mean like B squared equals to A squared minus C squared. So in this case, we put in the value of A, which is 6, and the value of C, which is 3, into this form, which will be equal to B squared equals to 6 squared minus 3 squared, which will be 36 minus 9, which is 27. So B is square root of 27. So the equation of an ellipse is given as x squared over b squared plus y squared over a squared equals to 1 when a is larger than b. So in this case, we can change it into x squared over square root of 27 squared plus y squared over 6 squared, which will be equal to 1. Then in this case, it will become as 27 x squared over 27 plus y squared over 36 equals to 1. And this will be the standard form equation in Cartesian coordinates. Okay, the question will be sketch the parabolas and ellipses, including the directrix that corresponds to the focus at the origin. Label the vertices with appropriate polar coordinates and label the centers of the ellipses as well. So the given equation will be r equals to 25 over 10 minus 5 cos theta. So this, what we can do with this equation will be, we can change it into another form, which will be r equals to 25 over 10 over 1 minus 5 over 10 cos theta. We divided this side of the equation by 10 altogether, so this will become 1, this will become 5 over 10, this will become 25 over 10. So this will be equal to 5 over 2 over 1 minus half cos theta. This equation will be changed into this form, which will be r equals to k times e over 1 minus e times r cos theta. What we did with this equation is that we found out that k equals to 5 and e equals to half. So in this case, we will get x equals to negative 5, which is the directrix. And since e is less than 0, we can say that it is an ellipse. So how to find the center for the ellipse is that we type in, we put it into this equation, which will be ke equals to 1 minus e squared times 8. So in this case, 8 times, we put in half for e, which will be 1 minus half squared, equal to ke, which will be 5 times half. This will be equal to a times 1 minus 1 quarter minus 5 over 2. Which will be 3a over 4 equals to 5 over 2 So in this case, we will get a equal to 10 over 3. So how we can get the center of, we can get that EA equals to half times 10 over 3, which will be equal to 5 times 3. So in this case, we put the directrix first, which will be x equals to minus 5, as we did it in the previous paper. And we can see that 5 over 3 is the center of the ellipse, so we put it in here, which is 5 over 3 times comma 0. And what we can do with this vertices is that we put in a 0 into here, which will be 10 minus 5 cos 0. So in this case, we will get 5, since cos 0 is 1. So it's 25 over 5, which is 5. So we get 5 comma 0 for this vertex. And this vertex we can get, we put cos pi, so which will be 25 over 10 minus 5 times cos pi, which will be cos pi, since cos pi is negative 1, we can get 10 minus 5 times negative 1, which will be 15 together. So which will be 25 over 15, which will be equal to 5 over 3, and this is the coordinate, so it's 5 over 3 comma pi. So the graph will look like this.